Good afternoon, everyone. Thank you for attending our Challenges Designing and Manufacturing Lithium-ion Battery Packs webinar. My name is Ryan Wood, the Content Marketing Manager here at Epic. Before we get started, I just want to let you all know that you'll be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel located in the webinar control panel, and we'll try to get to them all at the end of the presentation. If we don't have time to go through all your questions, we'll be sure to reply back to you by email. Also, we'll be recording this webinar and we'll be posting both the recording and the slides on our website and YouTube channel. Our presenter today is Randy Ibrahim, our battery development consultant. Randy has been active in the battery and battery charger industry since 1996. His 30+ years of experience in military, medical, industrial, and high-volume consumer industries has given him a unique advantage when qualifying battery designs for use in these industries. His work includes pioneering the development of custom safety circuits and battery chargers for unique applications and chemistries. And as a result, Randy has received numerous patents in his area of work and has written numerous articles for industry trade publications. So without further ado, I'll pass it over to Randy.
All right. Thank you, Ryan. I appreciate the intro there. And as Ryan had mentioned, today's webinar, we're going to cover the challenges, designs, and manufacturing of lithium-ion battery packs. And to cover this, there are mainly 4 areas of interest. First of all, we want to go through the benefits and maybe some of the downsides of some of the off-the-shelf battery versus custom, because that's always an option. We don't need to always go custom. Sometimes it makes a lot of sense. And then also, if we decide to go custom, how do we define what the battery requirements are? I mean, that's a whole thing that we need to cover in detail during this presentation. And also, once we have a pack and it's developed, where should these custom batteries be manufactured? We have a lot of different variations on that and locations that and options that we can cover. And also, how much time is required to develop a custom battery pack to get it on the market? We'll cover some of that, but I'm sure there's a couple chuckles in the background right now. So first of all, let's go through some of the benefits of using a off-the-shelf type battery. First of all, as everyone knows, they're very cost effective. They're mass produced, readily available, and it just makes it more cost effective if you don't have very complex battery needs. These are usually, they can be purchased large quantities, available in large quantities, and also it really can help your production deadlines if you don't have very complicated needs. And so there's a real market for these type of batteries. A lot of these batteries, since they are mass produced, the manufacturers kind of go down the middle of the road. They try to encompass as many type markets as possible and get the regulatory marks accordingly. And so there's a good chance, at least 70–80% chance, that these batteries actually could fit, and they could be just a UL recognized component, which would make it very easy for you to implement into your product. And also the integration, if you don't mind, usually these are kind of rectangle, kind of square bulk batteries. If you don't mind that form factor, it could be pretty easy to integrate into your actual product. Some of the downsides, of course, limited customization. Anything that's produced, these manufacturers usually have very little interest in talking with you about adding custom features. That's not where they make their money. So that's going to be a big problem with off-the-shelf type batteries. Compatibility issues. If you are looking for anything other than very simple communication and a plus-minus wire coming out of this battery, you might be hard-pressed to be able to work with your product if you have unique features. And also, intellectual property is sometimes an issue with these type of batteries. You may not have full access to the design, and you may not even know the quality materials used, where they come from, how they're sourced. That could be a real issue. And also, one of the biggest problem we get from customers when they come knocking on our door is a change happened. They use this off-the-shelf battery without any notice, something changed. They don't know what, it just doesn't work with the product because maybe their product uses a kind of fringe parameter of this off-the-shelf battery, and the off-the-shelf battery manufacturer didn't think it was a big deal changing, because 99% of their customers wouldn't have a problem with it, but it so happens you might have a problem with it. So something that's really important that you need to factor in when choosing an off-the-shelf battery. Again, no quality control. You don't know who the manufacturer is. You can maybe go with a more reputable one where you might have better luck, but sometimes there's a hit and miss. If you have a product that's not critical and like not life support, what have you, so maybe off the shelf might make sense. If you have occasional failure, it's not the end of the world for your product. So let's say that because of any of those factors, you decide, wow, okay, off the shelf is not the way to go. We really need to start seriously considering some of these custom batteries. So going down the list of the real benefits here, obviously, you can customize it to anything you want. The sky is the limit. You can really tailor it to your needs. To get the best performance possible, the best life versus some of the, cost trade-offs there. Definitely worth looking at from just being able to have a custom tailored battery for your needs. You have a lot of control over the design as much as you want. Some customers come to us and say, hey, just these are our basic parameters, build it and we deliver. Other ones are intimately involved in the design, which we encourage as well, because that way they have skin in the game and they know exactly what they're getting, no surprises. A lot of times having this type of control is really important because of component traceability, especially in the medical industry. Off-the-shelf batteries are really not an option for a lot of medical devices because of the stringent requirements to be able to control down to the actual component level by date code, everything else. That's absolutely impossible with a off-the-shelf battery. So that's a huge advantage. Another item is if you have more complex need where the battery is actually an integral part of your product, or sometimes your product you can't fit everything in. It's a small product. Sometimes we offload some of that onto the battery, which is like a battery charger, for instance. So there's a lot of things that we can put on a battery that will make it very unique for your product and make it integral with your needs. So there's definitely a lot of benefits there. But with all good things, there's the bad things, right? So obviously the first one's higher costs. Unlike the mass-produced off-the-shelf battery, where all that development cost, tooling, everything is all amortized over millions of units. Here, if you have really low volumes, the cost can be substantial because now you have all the tooling, you have all the NREs, everything that you come in and is amortized over a small volume. That could be a higher cost, but depending on your market and in your needs, that may not be an issue. Higher cost is all relative, depending on the end product. A longer development time. You don't have the advantage like with off-the-shelf battery. We have to start at time 0 and you're going through the whole development time frame. So naturally it's going to be a much longer experience that you're going to see. With the off-the-shelf batteries, you're starting at where the batteries are offered in production. So it's very quick and timely. We're here, custom batteries, it's definitely a longer time frame, which we'll cover a little bit here in the later slides. And also it requires some the specialized expertise. Some of the custom battery engineers, some of the manufacturing engineers that have a lot of experience. These are not your everyday type products that you just put out. We have some hazmat materials that we use, and special needs and knowledge expertise that may not be available in your house, but Epic has a lot of the expertise because they specialize in it. And also the manufacturing challenges. These custom battery packs require some specialized manufacturing processes, some unique test equipment, also safety equipment. We have fire extinguishers that have copper powder. I mean, I don't think of too many manufacturers out there making the core product have that type of fire extinguisher sitting around, which you need for a lithium-based type safety. So let's say we decide to go down the custom path because the off-the-shelf battery just doesn't meet our needs. So what's next is we need to really carefully look at and develop a good specification that's tailored for your product, because the better we can do this homework up front, the less change orders come down the pike, the less unknowns or, oh, I forgot about that, or we should have thought about that. All those things become a problem. We'll go into a little bit of detail as we progress through the presentation here, but here's kind of the highlights here. Obviously, the things we need to look at and define up front is the battery chemistry selection and also cell selection sourcing, which we'll go through, and also the battery capacity and voltage requirements. How does it fit with your product? They come in all different sizes. We can configure them differently. It all has to be tailored to your product. The shape, size, constraints. Obviously, the sky's not the limit. You have specific needs, and most of the times when people are coming around for a custom type battery, they have usually a very unique form factor is what they're trying to battle, which off-the-shelf batteries absolutely cannot address. And then thermal management, what type of environment? Where are we looking at? Where's this battery live? Is it in the product? Is it outside? Who knows where? And is indoors, outdoors, inside your core product? Thermal management is extremely important, which we'll cover. And then safety features, that's usually dictated by the regulatory agencies. And are you a medical product? Are you a consumer product? Big difference in the safety features that are required. Firmware integration, do we have to talk to this battery? Do you want to extract data? Do you want to get lifetime data? Fuel gauge data? Do you want that little display, a little battery symbol that shows the percent capacity? Those type of things require firmware, and we can communicate with your product, with our battery, so we can discuss that and how that's accomplished. Design verification testing. Once we have all this figured out, now we have to, once it's designed, we have to verify that each one of those parameters are met, and that we want to lay that out up front so we understand what's required from a test standpoint and who's responsible for that test. Also safety regulations and certifications. It depends on the industry that we're trying to serve. That varies all over the map. And then supply chain management, obviously in the last few years, that's been raising its ugly head, and it becomes more of an issue now that needs to be kind of spelled out here up front what the expectations are. And ultimately, here's the cost. If we got to make sure that this roadmap here for product development is closely followed, and if we deviate much, we need to document that and also circle back and say, hey, how's that going to affect the cost of this? Is it still a viable product? Because you might be in a market where it's very, very cost sensitive, any addition of additional features that engineers love to do, and there's always that scope creep. We've got to make sure we circle back and make sure the marketing department is happy with those changes, because they ultimately will affect the cost. And sometimes you come up with a product that's absolutely not viable, you can't sell it because you just can't compete in the marketplace. So cost is extremely important. So digging in a little deeper here, the chemistry, obviously that's all these different chemistries have a tremendous amount of trade-offs. I mean, you could spend a whole life just on the chemistry itself. It's performance trade-offs, and that's what we're here for. We're the experts. We can help you, guide you through this path, because there's thousands of variations. And what we want to do is we want to choose that chemistry that really balances your needs in your application. Is it energy? Is it power? Is it voltage? I mean, what is it? Is it thermals? Every product, every industry is different, and every application is different. This is such an important topic that we have a couple of webinars we've done in the past, just a couple of years ago. We look at lithium-ion. Everybody says, oh, lithium-ion. Well, what about nickel metal hydride? There's a lot of benefits to it. There's a great webinar, and these are located on the EPIC website. And not only battery webinars, but there's a lot of good stuff. EPIC covers, flex circuits, bridges, boards. They cover everything. There's some really good stuff, cabling, you name it. EPIC is experts in a lot of different areas, not just batteries. And so there's kind of a full one-stop shop for all your needs. I would strongly recommend go to the website and look up these webinars, and you'll find a lot of other webinars that do not pertain to batteries as well. And also in 2019, we did one, considerations on portable devices, especially in the military. You might want to look that up, and some good information out there. Then going into the cells, a lot of people get cells and batteries mixed up. Cells are kind of the building block to a battery. Some batteries actually have one cell in it. That's cell phones are classics, but a lot of batteries you have 3, 4, 5 cells, and they actually make up the battery. So the cells are really important. There's a lot of different manufacturers, all different quality levels, different energy densities, everything that in the safety levels, and depending on what part of the world you're buying these cells from. So it's really important to understand how to select these cells, why you're selecting them, and what are your criteria for the selection. And we have access to a lot of different cell suppliers, from very inexpensive to more expensive, maybe certain parameters that meet your needs where a cheaper cell cannot. We can definitely walk you through that. And here another webinar back in 2015, how many cycles can I expect? Different chemistries. It still pertains old. It's an old webinar, but it's still pertinent today. And then we need to look at the capacity and voltage requirements. The actual product that we're going to be powering, a lot of people think, oh, I just need a battery. Oh, simple, no problem. Okay, here's a battery. But you got to consider that batteries in themselves are not power supplies. A lot of people get the two confused. Batteries are just an energy source. They're not a power supply. So a lot of people say, oh, I just need a 12-volt battery. Well, that 12-volt battery is really not a 12-volt battery, because when it's fully charged, it's maybe up to 16 volts, and when it's discharged, it might be 10 volts. So it has a full range, and you got to make sure your front-end electronics can handle that range. Let's say that we're trying to retrofit this battery back into a product where you didn't take that into account, or let's say we're introducing it to a new chemistry that might have a wider voltage range. And it's really important that you utilize that full range, because if you don't, you're not utilizing the full energy content of that particular battery. So what we do is we look at it and we say, oh, okay, this is a good match because you have limitations on what your input power, what you can accept is appropriate for input power. And let's say that we have an older product that it can't handle quite that range. We can actually put on power supplies, DC-DC type converters on the battery. So we actually turn this battery into a power supply. So we put the electronics on that can handle the full range, and yet we supply a very nice conditioned output voltage that your product will love. And yeah, we can marry up the best of both worlds. So the battery capacity voltage requirements extremely important when you're factoring and looking at a battery and what to do and what to use. And also there's protection circuits have to be included with all batteries. I mean, all chemistries. It's just not lithium packs. You look at even nickel metal hydride. We put in like clip-ons and some PTC current limiters, resettable fuses, all chemistries. I mean, for instance, even your car, a lead acid even has fusible links. I mean, everything has that protection. And it's just the lithium-ion world, we just add a little extra layers because the chemistry is a little bit more volatile than other chemistries. Now, if we look at the battery shape size constraints, again, I mentioned a little earlier, this is one of the primary reasons why people will come to choose to pick or design a custom battery, because they just cannot find something off the shelf with the unique features. For instance, this medical battery fits on the hip. It has to be curved. It has to fit on the hip. It has to have that comfort. But when you provide what the shape needs to be, or tell us what it needs to be, that also dictates what type of cells we use inside, the shape of the electronics, what size, what space do we have to work with. And so size constraints is extremely important to spell out upfront before the project starts. Now, thermal management, this one just cracked me up. I've done this, oh boy, the last 15 years with Epic, great team to work with. And I learned over the years, don't do the graphics, just hand a stack of black and white, slides to the Epic marketing department. They do an incredible job. And so I get this back an email, and I'm like a kid in a candy store, can't wait to unwrap this email and look at it. And I'm always going, ooh, ah, what a beautiful slideshow. And I get this to slide 14 here. I'm sitting there, why is there a cart with batteries on fire? One of the things as battery engineers, we don't like putting in the same sentence as the word battery and fire. So Anyway, I looked at that, I got a good chuckle off of it. So I said, there's a reason he put it on wheels. So looking at thermal management, this slide's a little bit more accurate for what we're talking about here. We really need to look at thermal gradients closely. If you look at this particular picture here, you look down through here, we've got air flowing into this cavity, and the cold air is cooling off these cells. They're in blue. And as it progresses through, picks up more heat from the cells, dissipating heat. And a lot of times the more the inner cells are heated versus outer. So this could be an interesting model. But see the cell way over here, the red one, that will dictate the aging of the pack, that one cell. And so we got to make sure that the thermal gradients are as even as possible. Normally, when we see something like this, we'd rotate it 90 degrees if we have that luxury, and have the air go across all the cells. That way they all are exposed to the same thermals, and we don't get that. There may be all that mid-sized blue color, greenish color here, and that way they all age equally. Very, very important. But let's say we don't have that luxury and we have to live with this. Then what we do is we incorporate temperature sensors, so we can have that in our battery, in our gauge, and we can communicate that to the end product and end products and say, oh, okay, we're having thermal issues. Let's throttle back on our processor speed. Let's make these adjustments so we can prolong the battery life if that's what's desirable. So thermal management is extremely important. So going into our safety features, we've got standard plain Jane off the shelf right here. You know, some safety circuits, voltage detection, FET integration. FETs are nothing more than field effect transistors. We put them back to back, so they act like kind of like an ideal switch. And you know, once in a while you're gonna have a weird event, like let's say somebody shorts out a couple wires. Okay, we don't want to blow a fuse in the battery and then have to return the battery or throw it away. We just have these, they're kind of like circuit breakers. They're resettable and they do it automatically. So the end user doesn't have to think about it, short it out, no big deal. A couple seconds later, it re-energizes. We're good to go. No returns. And then we have sometimes the medical batteries require the secondary protection. Secondary protection is really important. It is a separate integrated circuit, separate paths, separate fuses, separate FETs. Everything is like a parallel path. So if your primary safety protection, let's say the IC burns up, the FET short, anything happens, we have this totally parallel safety system for overcharge. So we will never let the cells be exposed to an overvoltage event during charge, and which could result in fire. We don't like saying that word, but we do once in a while. And so that's where secondary safety really comes in handy. And also for short circuit, again, AFEs, we throw those in. They're analog front ends. We can turn these FETs on and off extremely fast. I mean, lightning fast, and they in the microsecond range. And that way, if you have a dead short, we don't blow up fuses, we don't disable packs permanently. And then let's say that these FETs, sometimes they do fail, it's possible. If they were, then we have a backup fuse where let's say you have a short, the FET doesn't open like it's supposed to. Okay, backup fuse is going to kick in, the pack is safe, no problems. And then we can also incorporate thermal runaway protection, and this is where Keith's slide pops right back in on his wheels because this is where it's appropriate. Cell spacing, if you look at this little image here, there's a little spacing between the cells, and we put those in because it's really, really, really important to make sure there's a physical barrier between cells, because if one of these goes, the other three doesn't. They don't have to. So you can minimize the severity of a event, of any occurrence or a flame out. They really don't happen much. We have so many safeties around that it's rare that you'd ever get that. In my 30 plus years, I've never seen a pack catch fire like that. We have thermal fuses in there too, to be preemptive in nature. So if a cell gets to a certain temperature that we know cannot happen in a normal environment, very, very high, we can actually blow a fuse that permanently disables the charge path for that cell. So it will not result in a flame. So that's pretty important here. Okay, touching on a little bit of firmware integration, communication protocols, uh, we've seen it all. It's very important that this battery can handshake with your product, and there's a lot of different protocols that we can utilize. Some of the I2C, SM bus, some of the CAN bus, more in the automotive area, full custom. Recently, we've done a half duplex communication conversion to I2C with the customer's help. They were pretty involved with that. And so we definitely like working with the engineers on the customer side, and together we can come up with a great product usually. Also, ensuring the operation is smooth between the customer's product and ours. We do work together and define these clearly up front, so there's no surprises. Design verification, this whole purpose of this is we have everything detailed, we know what the voltages, currents are, we know how this thing's supposed to run, we get the current profiles from the customer. Are there surge currents, are there not? I mean, what's the residual current, how long does battery last on the shelf before self-discharging? All these tests are done to verify, because everything looks great on paper, but until you are out there beating this up, we at the pack level in our labs, we'll go ahead and run through and verify everything that's called out in spec. On a system level testing, since we don't have access to the customer's systems and the environments they're going to operate in and the user interfaces, everything else, the system level is done by the customer, and with Epic's input, they come back and say, hey, this looks odd. Can you help us investigate what's going on here? So we're always here to help when the customer's doing the system level testing. And then if looking at the verification, some of the little details, mechanical testing, very important. We actually had one product, it's actually more through a UL test. A lot of this stuff here is UL test type procedures. And we actually had one product, we froze down to 0C, and it was kind of a heavier pack. But we thought, okay, great. One of the requirements are 0C for the UL standard, and we drop it 1 meter, boom, shattered like a glass plate. It was like pretty incredible. Anyway, so we went back to the drawing board on material selection and picked the right material, and got a very, very nice material for that particular product that doesn't shatter at 0C. Electrical testing, same thing. We look at, all the various voltage capacities, resistance of the cells. This all includes, some of the open circuit voltages, measurements, charge, discharge cycling. Does everything behave as designed, as expected within the parameters? In the fusing, everything, just the overall basic, beat it up and make sure it all works. Environmental testing, a lot of this is done, and this is usually driven by the regulatory agencies, and a lot of that's done per their specs at their facilities. And it could be a lot of things where temperature and humidity testing. And one thing to keep in mind with temperature, especially with lithium ion, if you're going to store this down in Arizona in the summertime, it better be air conditioned building, because that webinar I mentioned earlier on the slide about how many cycles I can expect out of a battery, there's actually a slide in that presentation that kind of correlates the exponential decline of a battery's health with temperature. Batteries stored at 60 degrees C only last weeks, and then it's an old age battery. You think, oh, I got a brand new battery packaging and everything's great. It isn't, because that battery is going to be acting like it's a 10-year-old battery. You're not going to have any runtime on it. So it's something to keep in mind, and definitely need to do your homework, and we're definitely here to help do that homework for you. The safety testing, of course, this is something that's required depending on what product. Medical product is pretty stringent, consumer products a lot less so, and we can work with our regulatory agencies with your product and determine what that is, what's involved. And speaking of regulatory agencies, here's a few. The most common ones in the battery world are the UL 2054. That's more for medical IT type batteries. And then also the European, also here in the US, the IEC 62133, that's really kind of overtaking 2054. It's actually easier standard to meet by far. So kind of seems backwards, but it's interesting. And then also some of the environmental regulations, depending what industry you're in, especially in Europe, the RoHS, the REACH are pretty important to be able to approve. And then this is a pretty important subject, so we've done a couple webinars on this for medical batteries certification just a couple years ago, and then a little older one on the lithium battery regulations and how they affect OEMs. All those can be found on EPIC's website. Supply chain management, this wasn't an issue until a few years ago, but obviously sourcing high quality components, even on less expensive products, there's no sense in not sourcing high quality components. They don't add much cost, and that just makes for a better product. And then also ensuring that the components availability and reliability is there. Availability, definitely the silicon expert is pretty good for predicting the life of a component. So you want to make sure that parts are not going to be obsolete the moment you start using them. Pretty important to kind of double check all that. It's a pretty useful resource there. And ultimately costs, very important, as I mentioned earlier. If you can build the biggest, best battery, and most engineers will want to keep adding features to it, and eventually it gets to the point where you can't sell it. So we got to keep circling back at cost, making sure that whatever we add to the battery can keep it under control. We can definitely optimize that using how we put cells together, how much material we're using, the customization of nickel straps. Do we use off our automated rolls, or do we have to have custom ones made? All that impacts the part. The trick is keep the material costs, the amount of materials, keep the batteries small, reduce the amount of material used. Material costs money, all of that. So there's a lot of ways to really keep the battery as simple as possible, but yet still meet your needs. And that ultimately that translates to a lower cost battery. And then what we're looking at here is once we have a battery design developed, and we're starting to go through the regulatory process, and even before then we start thinking about this. This is kind of the beginning of the project. We look at this, but we really need to look at where are these batteries going to be manufactured. In-house manufacturing versus outsourcing. A lot of customers say, hey, we got some good resources in-house. We can set up a battery line right next to our product line, and hey, that's great. We have some customers that do that, and but usually they're sizable in nature, and sometimes it makes sense depending on where they're located. But there's usually a very significant capital investment in equipment and facilities, also labor. And a lot of times batteries aren't made continuously throughout the year. You might have like first quarter, third quarter battery production. And what do you do with the personnel in between? Honestly, you can maybe cross-train them in other areas, but some battery personnel, they're not cheap because they're very specialized. And so those are the type of things you really want to look at. Outsourcing, like some CMs, like even EPIC, could be much more cost-effective. We specialize in building batteries continuously. It's our core competence, one of our core competencies, and it might make more sense to offload all that and not have to deal with all the expense and headache of meeting regulations and having hazmat material in your facility. Also, manufacturing location manufacturing, it can be offshore, domestic. The good thing with EPIC has feet on the ground overseas, 24/7, 365. Some of the lower cost Asian suppliers that EPIC works with EPIC employees on the ground, they're usually the lower cost, less complicated batteries, but we have the personnel to constantly monitor these, and you get high quality product overseas. And even though it's overseas, it doesn't need to be low quality, it could just be lower cost. And then on the state side, domestic manufacturing, that we normally deal with the higher tech batteries, medical, military batteries. And a lot of that's because of regulation and also engineering support. It also allows the customer to come in and audit more frequently, check on the product more frequently. It just makes for a better environment for these more complicated batteries. The communication is better and faster. So we offer that as well. We have a pretty high-tech facility to manufacture packs here locally. And the production capital expenses, kind of touch on that a little bit. It can be significant. You look at some of the equipment required. You got these welders, you got ribbon cutters. There's a lot involved. The calibration of all the equipment, the knowledge. Just welding a pack, it takes some really good knowledge of specialized welding processes, all different types. So pretty important there. There's a lot of expense involved with that. Custom programming test fixtures. A lot of companies will go ahead and they'll just have like one huge test fixture and works for a lot of different customers. We found issues with that. You can misset up a tester and then you can have defective product. We like making the dedicated testers for the products. That way there's no variances in setup. The same tester is used. We don't have variations in firmware for the testers. It works out really, really well. And also eliminates any bottlenecks in production. If you're running a lot of concurrent lines with different customers, no one's sharing equipment back and forth, which creates nothing but potential for errors. And then also some of the capital expenditures of packaging and specialized tooling, like for instance, this picture right here on the screen, the specialized foam is required for this wheelchair battery. And, very important for when you transport these batteries that they're not subjected to a lot of vibration and are treated gently. Supply chain issues, I think we all experienced the pain, especially 2 years ago. Last year wasn't so good either. It's getting a little bit better if we can get ICs at least. But some of the lithium-ion battery production, they really involve sources from all around the world. We source, especially ICs, from everywhere. And then a lot of these issues can creep up. We have disruptions in the supply chain, and I think we all remember this 2 years ago. That was quite the deal. And so with inflationary environment, price fluctuations can come into play here, and quality control obviously can affect availability. Obviously, if I find defective parts and you weren't planning on it, how do you recover from that sort of item that you were not expecting? And then all this can definitely impact the production schedule and also the cost of the batteries. It can definitely happen. We did one because of the pain and suffering back in 2022, last year, I guess. We did a webinar on that and mainly on how to deal with shortages and maybe how to design around some of the shortages. A pretty interesting webinar. You go check it out. So the last topic here is, okay, we're all down the path here, all hands on deck. We developed this battery and we're in the process of, and how much time does it really take to get a custom battery in the marketplace? First of all, it varies a lot of the complexity, the battery design. We have everything from, hey, a coin cell with 2 welded tabs, and there it is. There's your custom battery. Something super simple, very fast, easy, just a no-brainer. Then we got some full-fledged medical batteries with, we got to make sure we have a different charge input. We have a built-in charger. We have a DC-DC converter because it has to work from 10 volts to boost up to, 7 mil aircraft carrier, 27 volts, 36 volts. And then you got to make sure you can't charge on the output. Inadvertently, somebody plugs in something, puts current through backwards and bypasses all safety. So there's a lot of complexity that can happen on these various batteries. And so that will affect development time drastically, and the level of customization. I'll say what type of raw materials and components. Is there something super specialized, some gold-plated custom part, what have you? And also the regulatory requirements. It could have a huge impact. There could be a number, and how many certifications do you need around the world? All that affects development time. Overall, we're looking at these batteries from very, very simple. It could even be less than 6 months, coin cells on up to 2 years. We've had a couple go in the 3-4 year range, depending on how much testing is done, even on the customer level, because even the customer, doesn't quite understand because they're developing brand new products themselves. So, they have everything on paper, everything looks good, and then they build their own product and they realize certain things that might have to change in the battery because some unanticipated parameter on their product which is brand new. So we're used to it. I mean, we understand it, and we work with customers routinely, and so that doesn't surprise us at all. When the customer's blazing new territory, and we're trying to match a battery to also keep up with that blazing new territory. So it can be a lot of fun at times, or frustrating too if you're management, I guess. But um, it's really important ultimately to factor in, because there's so many unknowns a lot of times in brand new technologies, that when you do product launches, make sure you factor in some of this time so you're not disappointing the marketing folks. Pretty important to keep that in line. Way back 2014, Anton, when he was just a youngster, did this webinar on battery pack development time webinar. Took a peek at it. Still viable today. So looking at design engineering timelines, design phase obviously covered some of this, defining the requirements. As I mentioned, the most important thing, looking at appropriate cells, configuration chemistry, designing protection circuits, enclosure, electronics. We saw little sprinkles of that throughout this presentation. This can range definitely, from a few weeks on this particular phase, a few weeks to several months. Varies a lot. This is actually the most fluid part of the design process because it has the most number of variables that can get you. Tooling, obviously there's some parallel efforts here. We've designed plastics have custom horns and nests, specialized equipment that needs to be developed concurrently with the products, testers, what have you. This can take several weeks to several months, depending on complexity and number of pieces. Products have 4 or 5 different molded parts, they each one require molds. And then the testing element, we have when we're assembling the final product, we have to make sure the tests, we have good coverage of tests, and the batteries make sure that they can test as much of what the end, I guess the initial design requirements are. We want to make sure that there's some decent test coverage for that. And obviously this phase, some of it is done concurrently with the product development. It can also last, weeks to months. It depends on how many custom features the battery has, how complex. Do we use barcode scanners, read barcode, and also program that inside the battery so there's permanent keeping of serial numbers and parameters and test results. I mean, the sky's the limit. So this can vary from a simple go, no-go voltage test, which takes no time, to something that's very complex. So certification compliance, again, this is industry driven, starting to sound like a broken record here, but depending on the industry, and you've got to test at different levels. Also, are you testing around the world? Do you have world compliances? Obviously, we can leverage off a lot of different tests. We work close with various regulatory agencies to minimize the amount of pain required for different countries. And also the regulatory, if you're in Europe, environmental is pretty important. And some of the, international, what can we do and how much time does it take? And this also varies. I mean, it's something that even needs regulatory. Some basic parts that you're not selling in a big box store, you don't need UL. That's what the box store requires because of the insurance policies. So sometimes you don't need it. There's no federal law saying, hey, you need to have this. So it varies a lot from like no time to a lot of time. So I know it's all over the map, but bring your project to us. We can look at the specifics and then we can be pretty precise about the timeline required. This presentation really covers from simple to complex, so you can't really nail it down in this environment. So going through, I know I covered a lot today. I have a tendency to do that. I don't apologize. So, anyway, let's look at this. Okay, there's 4 points we covered here. The main thing is if you can get away with a off-the-shelf battery, by all means do it. If you're in that market, you're in that industry, and you can do it and make sense, go for it. Just make sure that you kind of cover yourself and do your homework with whoever you work with. Then if you do decide to go custom, really define that those custom battery requirements. It'll save you a lot of time and money if you do it upfront. Just minimize that cost, and it's very, very critical if you want to get a product to market in a timely manner at lowest cost. Very important to do that upfront. Once that's all done, and and you have the product all done, and knowing where the battery is going to be manufactured is very important, because there's a lot of cost trade-offs there, also quality trade-offs. Really understand that, and Epic is here to help with that, since we provide everything, a lot of different manufacturing around the world. We can be the point source to make that happen, and make it happen very smoothly for you. And also the last item here, the takeaway, definitely, if you're a fan of heart, don't go custom. It does take time. I think most people understand that, but the trade-offs could be enormous in having a viable product, because a lot of products could not be on the market if they were not if they didn't incorporate a custom battery. So it definitely is something worth pursuing. So just real quick, I'm going to hand this over to Ryan. Epic does cover a lot of products, which Ryan will cover.
Thank you, Randy. While Randy reviews the questions that came in, I wanted to briefly mention some of the additional PCB-based products we offer here at Epic. Custom battery packs, flex and rigid flex PCBs, cable assemblies, RF products, high reliability user interfaces, flexible heaters, and our energy efficient fans and motors. Next slide, please. All right, I will turn it over to Randy. He'll go through some of the questions that came in.
Oh man, expect I'm a speed reader, huh? I was hoping a little more time, but okay, we're gonna have to add a little here. Okay, I got good response here for a Friday. I'm actually kind of surprised. So let's see here. I'm gonna normally have a little more time to read through these, but okay. Here's a good one. Okay, first question here is, can chemistries other than lithium-ion be used in custom batteries? Oh yeah, absolutely. No, we've actually done all. I mean, we can add fuel gauges to all chemistries. We have that capability. Also, custom electronics, you name it, anything we do with lithium-ion, we can do basically with all chemistries. And also we can make them any size and shape. In fact, I think one of Epic's products, I wasn't involved with it, but I saw it when I was out at the manufacturing. It was actually using alkaline cells, kind of like those D cells you see at the checkout line at your grocery store. Anyway, we can weld all those up, and they totally encapsulated them for making water resistant. And it was a pretty cool design with a special harness, everything else. I mean, here we are, just alkaline cells. So sky's the limit. We can make anything custom. If you have a special need, even that one-time use alkaline cell, hey, we can absolutely do it. And so let's see here. I'm going to go. Okay, there's a couple of these I think are pretty involved. That's another code word for saying I don't know the answer. But okay, here's one. Okay. What are the most important factors to consider when choosing a lithium-ion battery cell for a custom battery pack? Yeah, that's pretty cool. First thing that comes to mind would be looking at the energy density, because usually when people come to us for a lithium-ion specifically, and not other chemistries, usually it's a portable type product, and with those we look at energy density. And usually we want customers looking for something, a huge amount of energy in a very small package, and it's lightweight. And so we look at those cells. But along with that, we would want to factor in what the discharge rates are, because in the lithium-ion world, we have basically two cells out there. There's what they call an energy cell and a power cell. You'll see the power cells in your drill batteries at Home Depot. Those are all power cells. They can deliver a lot of current in a short amount of time, and the battery itself doesn't overheat internally. And that's because the structure of a power cell, they're usually lower energy density because they use up extra space in there to have conduits to deliver extra current and without voltage drops within the cell. So those are power cells. Energy cells have a lot thinner current delivery devices built into the cell, so they can pack more chemistry in, so they actually run longer, but you can't draw a lot of energy out at a really fast rate. So those are called energy cells. So those are the type of things we look at. And then cycle life is sometimes important. Maybe a lithium iron phosphate cell would be considered a little heavier cell, but they can get, like 2,000-3,000 cycles off those cells versus maybe 500-600 on others. So those are the type of things we'd factor in and work with the customer, talk to them about them. Safety, obviously all lithium ion, we need to wrap around a fair amount of safety around it. Lithium iron phosphate, less so. They're a little more robust in the safety realm. Also really important is temperature, because with lithium, in the old days, lithium was ruled out for like window blinds because it was too high temperature. They're getting a little better now, so we can incorporate them in some of the higher temperature, type of applications. So those are type of things. I don't know, you could look at voltage, but I think that'd be it in a nutshell. Hopefully that answers that question. Let me see, going through, trying to find ones that are easy to answer in a timely manner. Okay, here's a good one. Okay, how can thermal management be incorporated into a custom lithium pack? Kind of alluded to this, didn't really touch in any great detail, except for cell spacing, I guess, but the heat dissipation, we got to really look at how heat is handled. And a lot of times a larger enclosure is better because we can dissipate the heat better. We actually sometimes put heat spreaders in a pack if there's too much heat. A lot of times if we have a battery charger built into the battery, we have to pull that heat out. And so sometimes we'll use a metallized heat spreader and use a thinner enclosure to dissipate that heat, manage it a little bit better. Also, trying to think here, probably also, maybe thermal interface type materials would be useful. Meaning, in fact, we have one project we're working on that we actually use a really highly insulated material, because the problem is heat coming from outside, like autoclaving would be a good example. Heat coming from the outside causing too much temperature inside. And so the trick there was to use a very highly insulated material, like even the aerogel could be used, and make sure that cells inside the pack have very low internal impedance. Make sure all the FETs have low RDS-ons, all the thermal path or the traces, everything's low resistance. So when you're actually running this battery, it in itself does not produce a lot of heat. Then you can use these type of really nice thermal insulated materials to prevent heat from going in the battery. Obviously, these type of products can't be used in certain environments. You're going to have environmental limitations, like for instance, if you're in a surgical room, those are normally pretty cool environments. So we can that would really help us in this situation. But if this battery's outdoors on a dashboard of a car, then we're going to have a totally different approach. Boy, what was the question? Okay, how can thermal management be incorporated in custom lithium-ion packs? Boy, another thing maybe come to mind would be like almost like Tesla. You have active cooling, passive cooling. Tesla uses active cooling, where every single cell they have this liquid that goes around every single cell. I have in my lab 1/16 of a Model S pack. Pretty interesting how they designed it. And so all the cells, they prevent thermal gradient, like that little slide I showed earlier. And they do all that by active cooling. So they're not relying on the inner cells pulling out heat. And if you didn't use active cooling, those inner cells would get hotter in a Tesla. But since you have this nice little cooling channel with liquid, even the inner cells are exact same temperature as the outer cells. and they can preheat on a cold day. So active cooling is, and also active warming is pretty important. And let's say that you don't have the money, you don't have the budget for this, and you can't sell the product. So back to that slide where we had temperature sensors, there again, you can control this you can manage the thermals by having these temperature sensors and having the product adjust its behavior so it can get the temperatures under control. Throttle back on that processor, slow down the motor if possible, if that's a viable solution. But sometimes the end product does have some flexibility, and so the battery can scream out loud to the product and prevent some of those temperature issues. I don't know, off top the cuff, I don't know. I'm sure later this evening, probably come up some others. Oh, let's see here. I think you have time for maybe one or two more. What what are the less common safety features that should be incorporated in a custom lithium battery? Yeah, we did cover all the the basic high level ones. You got voltage, over voltage, under voltage, short circuits, all that good stuff. But on this one here, I think second tier, third tier safeties, a lot of times they're there, but we don't really discuss them. One of them, one that does come to mind would be maybe cell balancing. A lot of people think of that as more of a cycle life feature, where if you can keep all the cells balanced, it's kind of like an ice cube tray. You fill it with water real quick, and you kind of wiggle it around so all the water is at the exact same level. Same thing with cell balancing. So where that could come in, that really helps the cycle life. So if you keep them all balanced, you can get a lot more cycles out of your pack. But a really nice side benefit is if you incorporate cell balancing, you don't ever let one cell get really, really low or one really, really high, so they're out of sync with all the other cells. Because if you have that one, your safety circuits will kick in, the low side and high side. So the perception to the end user would be, wow, okay, this pack is not good. It'll only get 50% runtime because you're hitting these limits. But the other thing is, let's say something goes wrong with maybe some of your safety circuits. All of a sudden now these cells constantly excursion to the low side all the time or the high side all the time. That can also have impact on dendrite growth within the pack. It could be causing some issues uh, with the pack that could affect the separating material, and that could ultimately cause an internal short. So yeah, cell balancing could be considered a safety feature if you stretch it a little bit. A couple other things would be like kind of, we encapsulate some batteries, some really cool stuff on the Epic website about that talks about encapsulation and potting materials, what have you. One safety feature is pretty important to put in those type of products would be gas release. All these cells have little ways where they do vent. They're very controlled. They usually have like a perforated metal, little star pattern. So instead of just blowing up randomly off the side, it usually on the top cap there'll be a little pressure relief, and a lot of cells have it. And it's important when the cell does vent for whatever reason, that gas goes somewhere. So especially an encapsulated type set pack, a lot of times we'll put in a open cell foam, run it along these caps before we encapsulate them, and run that out to maybe a Gore-Tex type material that has 1 meter depth, submersion depth without penetration. And that way there's a nice little channel for gas to leave the pack, even though it's encapsulated. That's kind of cool stuff. And then a lot of these cells have built in the CIDs. One of my presentations on that, it's a secondary protection that I did in 2017, talks a little bit about the CIDs. They have built-in safety, lesser known. Those are current interrupt devices, and it's kind of catch-all. If your fuses fail, everything else, the cell itself can protect itself. And a lot of cells have that feature built in, which is a pretty good feature. I don't know. Trying to think of it. Boy, the only other thing I can think is my original RV, had a battery disconnect feature, kind of old school, but it was a little lever, right? Disconnect that. I mean, that's a safety feature. I don't know. Other than that, maybe some, flame retardant materials. Make sure all the materials in your pack have high temperature ratings, so you don't propagate flame if something were to happen, or they don't catch fire just because they're low temperature rated device. In any insulation, thermal barriers, fish paper, things like that. Make sure those are all rated for high temperatures. That'd be safety features that are lesser known. But yeah, outside of that, I can't really think of anything else to add to that. So I think do one more, and let's see, yeah, we're seeing 1 hour. Do one more. Let's see. How can a company ensure the quality off-the-shelf battery is up to their standards? So yeah, obviously you don't have any control over off-the-shelf batteries, but there are certain things within your control. I would personally define some sort of quality standard and requirement. I'd communicate, find out who this company is, talk to go visit them. You know, even if they're overseas, go see them. Define what your quality requirements, expectations are. Really get that down. It's pretty important, and also work with only reputable manufacturers. I was actually with Epic over in Shenzhen, China, qualifying cell manufacturers out there, and boy, it was an eye opener. Some of the ones, I mean, it's good that we do the research. Some of them, you know, you walk in the room, their whole body was covered with lithium powder. I mean, their eyes, everything. It's like we would turn around and walk away quickly. So do the same thing with battery pack off-the-shelf manufacturers. Go into those facilities. Are they filthy? Are they unorganized? You know, if they are, turn around, walk away. Don't use them. Evaluate them. Go see them. The other thing is requests. And we actually did this with a power supply company. Request documentation, and it's super important to verify, you know, because they had the UL numbers, everything. We actually looked it up in the UL books. It didn't exist. And so it's like, okay, they have all the beautiful marks and everything. Check, make sure those are not just fake, you know, very important to do. Sample, I would also get samples. We do that with a lot of different products, and just don't order it from them. You know, have friends order it, have different companies order samples, so they, you know, you don't get an assaulted version that's perfect and has the best capacity that you're looking for. Just make sure you're getting random samples, and do it often. Even after you're purchasing from them, maybe you're down the road, you know, get samples, verify that they still meet the standards that you're looking for, runtime, voltage, everything, whatever is important to you. That's what I would be doing. But I don't know. Go custom, hire Epic. I think it'd be a better choice. Anyway, that's it for now. And again, any questions we didn't get to, we're going to be responding back via email. All questions will be answered in a timely manner. And I really appreciate everybody's time today, and thank you for putting up with me. And have a great weekend and enjoy this evening. Take care. Thank you.